Understanding multipliers in computer architecture. This presentation explores the fundamental role of multipliers in digital logic and computer systems. We will cover their function, operational behavior, and diverse applications in modern architecture. So, what is a multiplier? A multiplier is a data selector. It selects one several input signals. The selected input is then forwarded to a single output line. So the core function is like it acts like a data switch. Its direct data flow controls signals, determine which input is choosing. So it's like you are sitting with your friend, maybe four of them. Each of them want to talk to you, but you can only listen to one person at a time. So what do? You use your finger to point to one friend and say, "You talk now," and only that friend talks. That pointing finger is like a multiplier. So a multiplier is like a magic switch. It helps you to choose one person or one thing for money. So that is how multipliers works. So we have internal behavior of a math. So internal behavior of a multiplier. So a multiple input. A max accepts two n data input. Each input is unique. We have the selection signals. And selection signals control the inputs. These lines are binary coded. And we have the internal logic. The logic gate internally routes the choosing input. Only one input path is active. We have the single output. The selected input data appears at the single output. We have multiplier operations. Data selection. Based on selection lines value, one data input is choosing. And we go to the signal routing. So the max routes the selected input. It effectively isolates other inputs. You have the time division. Can share a single communication channel among friends sources. You can share a single communication channel among multiple sources. And we have the control logic. The selection acts as the control. They dictate the multiplier's behavior. We have the input characteristics. We have the replicated data, the active high low, and the propagated delay. So the replicated data, the output is an exact copy. It mirrors the selected input signal. Active high low, the output polarity depends on selected input. It can be active high or low. So you have common types of multipliers: the 2-to-1 multipliers, the 4-to-1 multipliers, the 8-to-1 multipliers, the 16-to-1 multipliers. So the 2-to-1 multipliers, so two inputs, then choose one selection. So 4-to-1 to you choose, so 4 input, then you choose one. 8-to-1, 8 selection, you choose one. 16 selection, then you choose one. Applications in computer architecture. CPU design. The multiplier select data path. The route registers to ALU input. We have the memory addressing, the data transmission, the circuit simplification. Then we go to, so multipliers are vital components in digital systems. They enable efficient data routing and resource sharing. So in computer, a multiplier is used to choose the data. So choose which data should go to the CPU, help save space in the memory, make everything work faster and smarter. Even though we do not see it, The multiplier is always working behind the scene like a superhero, helping the computer make decisions.